to Chemistry 410. Today we're doing experiment number 2, the silicone polymers experiment. So we need to measure out some ether and this dichlorodimethyl but the first thing I'm going to do is actually clamp up my flask and drop in the stir bar, just so those are out of the way. Next thing we need to do is measure out 30 milliliters of diethyl ether. Just a little bit over. So there we have our 30 milliliters. And next we need 15 milliliters of the dichlorodimethyl. You want to be careful with this. This can be pretty nasty to breathe. Make hydrochloric acid if it reacts with water in your nasal passages and whatnot. Almost there. And there we have our 15 milliliters of dichlorodimethyl. So now that those are in our flask, turn on our stirring. And then the next thing we need to do is assemble a condenser on the top of our apparatus here. So start by putting that in like that. I've already got clamps set up. Clamp that up. Then we take our water inlet, so that will be the green one here. It's always good to have this secured with a zip tie. And we'll put this onto the bottom of the condenser. And then secure that as well with a zip tie. It's always a mess to have these come off and have water all over the inside of your hood. So then we have our outlet hose, which goes down into the drain in the back of the hood, which we will then connect to the top of the condenser. Here we go. And we can secure that one with the zip tie as well. Looks like we'll need a little more hose actually on the glass there. Okay, and then of course you need to turn on the water. So we do this knob here, do this kind of slowly, and we don't need a fast flow. And that should be more than adequate for this experiment. All right, so we've got our ether and our silane here in this solution here, stirring with the condenser on top. And then I've got 30 milliliters of water that I measured out in this beaker here, and then I'm going to pipette it carefully into the top so that we don't get a crazy reaction here. So little at a time here. Whoa, yeah, see? Got a little excited there. It goes pretty slow. Get through a couple more of these additions, and then I will kind of tell once the reaction is more or less finished, and you stop getting so much of a strong reaction after that, adding water. But we'll add the rest of this, and we'll be back for the next step after this stirs for about 10 minutes. So, that's still got about 5 minutes left to stir. You saw some of that, and I've already added, as I've added all the water. But we need to make a sodium bicarbonate solution. So we're going to come over here. I've already got the 4.5 grams of the sodium bicarbonate weighed out. Use that here. So, and then we need to make a 45 milliliters of a 10% solution. So the way we're going to do that is I've got a little beaker here. Take our 4.5 grams here. Dump it in this beaker. And then we're going to add here, this is about 35 milliliters of water. So we're going to add a little bit less because we want it to be a total volume of 45 milliliters. So we're going to add this 35 milliliters. And then we're going to give this a stir so that it will dissolve for us. Pour the solution here. Still somewhat settled down. This stuff is very stubborn to dissolve. Pour that into our graduated cylinder. Then take this extra beaker, this is just some water. We'll top it up to the 45 milliliters total that we need. now. We've got our sodium bicarbonate solution made up over there. So at this stage we need to remove the layer of water from the top of our reaction mixture here. So we're going to turn the stirring off, let it settle, and if I put the camera over here, you should be able to see as the two phases of the solution separate. It might be kind of difficult to see. Hopefully that comes across. Anyway, it's pretty plainly visible when you're here. So what you want to do then is we're going to just raise up our condenser. Do that just by unclamping. And we'll just raise it up out of the way, clamp it up a little bit higher. And I've got a small beaker here, and a pipette again. And I will use those to remove that layer of water. The water will be the lower part. Water being more dense than ether, of course. So, now that all the water has been removed, we can add this 15 milliliters of sodium bicarbonate solution after we replace the condenser. Back in place now. We'll start slowly adding that sodium bicarbonate solution. I've got the 15 milliliters already measured out. Let's turn on our stirring. There's our 15 milliliters added. Now I'm supposed to let that stir until the bubbling stops. The water that I pulled off from the first time, I'm going to put in the aqueous waste. And we'll leave that to stir now. Okay, so our bubbling has stopped. This time we're going to remove the water layer again, and then we'll check its pH to see where we are. Looking for the pH to be no longer acidic. So let me get the condenser moved here out of the way, and then we can look at the pH of the water layer again. set it right there on the stir plate. Take our pipette. Just a little drop. On there. And let's see where we come out on the scale. So green. So we're looking for greenish. Which we're already greenish, I would say. Weakly acid. Yellow is weakly acid. Green is weakly alkaline. pH of around 8. I would say that we're there. Alright, so we can move on to the next step. So now that the pH of our water washings that we pulled off of our silane mixture, silane water mixture, is neutral or basic, we can add a little bit more water. So I got 30 mils of water here. And this will just be a washing step for our organics, or remaining organic layer. Go ahead and just pour that 30 mils of water in. Give that a good stir here. Maybe not quite that vigorous. And then for the next step, we can actually use a separatory funnel. So I'll get that set up. Okay, so now we're going to separate the water from the organic layers here, and since we're going to just do this for the last time, we can use a separatory funnel for this. Just pour this solution off into our funnel, which is closed up here on this little ring stand. It's very important that it's closed. You don't want it starting to flow through before you're ready for it. Pour everything through. Leave the star bar in the round bottom. You don't need it. Take that funnel out of the way. And then I'll just remove this guy for a second here. So you can hopefully see our two layers there. Organic layer on the top being the less dense, and the water layer on the bottom. So put that back here in our stand, and just turn our stopcock here and let the water layer flow out. You can let it go pretty fast until it starts getting to the more angled part of the funnel, and then you'll want to slowly kind of constrict the flow to make sure that you can cut it off in the right place. It's gonna go on, and there we go. So there's our aqueous waste. Got another beaker here, and we'll go ahead and put our organic layer in this beaker to be ready for the next step. What we need to do now is make a little syringe filter. So we're going to take one of these 10 milliliter syringes and make our little column out of it. So first, just take the plunger out. We don't need it. I'm going to get this little box just to not make a mess. Next we need is a little bit of cotton. There should be some somewhere around the lab. We just need a little tiny piece. That's about right. Take some tweezers. Kind of shove, that might be too much actually, a little piece of cotton into the tip of the syringe here, and that'll keep the silica from pouring right back out. This might be just a little bit difficult at first, but once you get started, you kind of just push it in there with the tweezers, hopefully. You can kind of see that cotton there in the top. So we're going to take our silica gel, take our spatula here, We don't need very much. We only need to fill it up to about the 2.5 milliliter mark. So let's see where this gets us. I guess I don't need that funnel after all. Scoop works just fine. And another scoop to get us where we want to be. Oh, not quite. Just about to 2 there. And a little over, but that's okay. Yeah, so we're shooting for about 2.5 milliliters, kind of on the syringe markings. Next, we need sodium sulfate. Get a different spatula here, and then we needed to fill it up another 2.5. So we'll have it full to about the 5 mark. So, get the sodium sulfate. And that was pretty close. Sides of the syringe get a little dusty. It's kind of hard to tell where you're at. Give it a little tap to try to level it out. There we go. Right at the 5 mark. We're going to take this over here and we will clamp it here in our little, oops, wrong part of the clamp to be playing with. It in our stand here. Kind of wobbly, isn't it? So we've got another beaker ready to go. So, and then we can take our organic solution from earlier and pour it into our little column here. Let's actually lower that so that we don't have it drip as far into the beaker we're collecting into. There we go. So, pour this through our little column here. That will make its way through, and then we'll also end up washing the column with another 45 milliliters of ether once we get to that point. So you can kind of see it seeping. It's almost to the 1 milliliter mark. You can see it there. Take our syringe plunger carefully here so we don't knock the syringe out of the holder. Give it a little bit of help pushing the solution through our little column here. Put the rest of it in there now, and then we'll get it washed with our extra volume of ether. Here's all of it. Over here, you can see my hand. I'm just holding onto the syringe milliliters of diethyl ether here. The actual amount we wash here with is critical to be precisely at 45 milliliters, so I'm just going to measure it approximately here with this beaker. More than accurate enough for just a washing step like this. Over here. Let's see, 45 milliliters. So just pour a little bit of that into our column here. And with any luck, once we get this first little bit through, the rest of it will just pour through pretty quickly. We'll have to push every little increment. So now our syringe, we want to remove the plunger and dump the silica and sodium sulfate in here into the solid waste container, which I'll show you later, but that's important that we do that. Okay, so now we have our ether solution with our silicone polymer in it that we push through the column, and we need to evaporate this. So we're going to put it on our hot plate here, and we'll just turn the heat on really gently, just give it a little bit of a turn. And then we need to push some, flow some nitrogen over this, which will also help to evaporate off that ether. There's a valve up there, this brass one, that we have to turn. So if we turn that, that will then start the flow of nitrogen. So you can see over on that bubbler there that we're flowing nitrogen now. Anyway, and then we can push nitrogen through this front part of our manifold, which we'll do by turning this valve so the black tape goes up. So we'll take this hose here, and we'll just clamp it so that we're gonna flow the nitrogen into our beaker here. Let's move it so that it's not gonna shove the beaker or knock it over. And we will turn this on. And then one way we can check is to just, you can hear the, you can kind of hear it. It might not come through with the other sounds, but you should be able to hear it in person. And so then we'll let that evaporate like that until we are down to a lot less solution and down to just our silicone polymer and no ether. So. Okay, I think our solution has evaporated all that it's going to, so we can turn off our heat and our nitrogen. So now that everything's closed off there, we'll go ahead and just remove the beaker from the hot plate here. Careful, this will be warm, and we'll just let that cool there for a moment. While we wait for that to cool, we need to weigh that silicone solution, or silicone I guess is all it is now, so that we can calculate how much boric acid we want to add to it. So, because we're doing it by weight percent with the boric acid. So I'm going to take this vial here and get its weight, or its mass. So we'll close the balance there. We'll go ahead and record this. You would of course want to record this as well. So this is our vial, our tare weight for the vial. So if we just hit the 0, then that zeroes out the balance on that number. So we can take our vial over here and carefully pour our silicone solution into the vial. then now that that's registering it as a negative, missing the value from our file there, close that. And this was just in case the balance didn't keep our tare, so it's good practice to record that kind of thing. Then we have 6.1157 grams. This is silicone. Take that out of there. Cap it so that it's good. So now we need to weigh out our boric acid. So we need to do, I'm going to do 5 weight percent. So that 5 weight percent is about 306 milligrams, or 305.8 if we round up to that last significant digit. I've calculated how much boric acid we need. We need basically 306 milligrams. So I've got a weigh boat already on the balance here. Here's our boric acid. There might be a different jar, but this is boric acid. So we'll take here a little bit. There we are, 308. Now we're a touch over. Let's see if we can get just a little bit off. There we go. So 306 point. What's the balance here? Perfect, 306.0. Okay, and then we will go on to the next step now. So now that we've got our boric acid here, take this spatula with us. So we've got our silicone here in this vial, getting ready to be warmed up with our. This is a very active sand bath here, just so we can heat this up, get it nice and hot. The boric acid here to our vial. This is not a good spatula to stir this with, so let me get a different one. Stirred up pretty good now. All right, and I'll keep stirring that and heating it, and we'll be back when it starts to gum up. I'll get back to stirring here because it's starting to get little solid bits floating in there. Needed to clamp the vial here so that it wouldn't roll around in the sand so much, and it was getting too hot to touch, so. This clamp is a little bit can see we're getting a, maybe if my hand's not in the way, getting a kind of a bit of a chunk of something in there, so. It's kind of foaming up a little bit. Oh, it's definitely getting more viscous now. Okay, I'm gonna turn the heat off. Oh, very viscous now. Yeah. So once that cools off a little bit, I'll be able to scoop it out of there and then knead it with my hands, wearing gloves of course, but I want it to cool off first. So I'll keep stirring this, and once it's cooled off enough that I can touch it with my hands, I will bring you back in. Okay, so here's our polymer. The vial is still a little bit warm, but I can touch it, it's not too bad. That didn't take very long to cool down. Let's see if I can kind of scoop this out of there. I'm just gonna kind of dump it on the bench here if I can. There we go. Doesn't really want to come out very easily. Come on now. Alright, well that's the majority of it. It's got kind of a lot of little chunks here. Just kind of gather them up. About kneading this into a ball. It's kind of brittle, unfortunately. I'm not sure why that is, but part of this experiment is going to be optimizing the, or seeing the effects, I guess, of the ratio of the amount of boric acid that's added in that last step there. This is not wanting to stay together in a very in one mass, really. It kind of keeps fracturing. So perhaps it got too cold before I got to knead it. You need to do it more when it's hotter. I'm not sure. But so yeah, one of the tests, we can use this larger piece that we've got here as kind of our example. So some of the tests that you'll want to, or the comparisons you'll do with this is how high it will bounce. So there we go, that's much better. But once you have a kind of a ball, you know, we'll be testing its bounce. And that bounces pretty good. And then of course the stretchiness of it, which this one is pretty poor at. So you can see it doesn't really stretch so much as it just cracks. So with that, we'll end this one and good luck. So another thing we want to do kind of to end this lab up is what we're gonna have you guys do with some of your glassware that's dirty after the end of the lab, and also some of your waste. So for instance, this beaker has some aqueous waste. It's one of the portions of water that we pulled off of the polymer as we were making it. And this hood here, which I've opened, has 2 waste bottles in it. One that says organic and one is for aqueous. So this waste we will just pour right into the aqueous waste. Be sure to cap the waste containers when you're done using them. Of course, if you had any extra ether or silane that you didn't need when you measured and you measured out extra, that would go into this organic waste, or in the future when you have other organic solution wastes that can go in this jug. Our little syringe column here, we can put in this container here for some solid waste disposal. So take this beaker now. Back. And of course, we should keep this hood closed, the sash closed as often as we can. I'm done with it for now. Another thing kind of related to waste is glassware. So if we have a bunch of pieces of dirty glassware here, what do we do with them? Well, to make the cleaning situation for the TA a little bit easier, it'd be nice if you guys could rinse your glassware when you're done. So depending on what your glassware last had in it, kind of depends on the order that you would rinse it with. So if it last had an organic compound in it, so this was the beaker that had aqueous in it, so we'll just, this bottle, this is something I used. So this bottle last had an organic compound in it, so we would rinse first with acetone, and then with water, and then with acetone again. So just give it a quick little rinse on the inside there. And then this waste bottle, which will be here, is for the rinsing. So it's for acetone and water. Rinse that once with the acetone. This little bottle is water. Give it a nice little rinse with the water. And then the final rinse with acetone helps get any of the extra water out, and it makes the glassware dry faster and not have spots on it. Bottle upside down over here. So, and then something that had aqueous in it last, you can do aqueous first, or water rinse first, and then rinse with acetone. And then depending on how dirty your piece of glassware is, you might need to do aqueous and then acetone again, or just the rest acetone rinse like that. But all in all, that should make the job of the TA a little bit easier and ensure that you guys have good clean glassware to use for the rest of the semester.